All right, so this is day 3 of the digital learning. You guys are doing pretty good getting through each of the assignments. I looked at Desmos. Desmos, and a lot of you are doing really great things. So we're gonna keep going. So today is exponential transformations. It's the good news about today's lesson is that it is very similar to transformations in the quadratic unit. All right, we're still going to have A, H, and K, and they're going to mean pretty much the same things that they meant in the quadratic unit. All right, so let's start with the parent function. So we know that with quadratics, we had a parent function that was y equals x squared. All right, but now in the exponential unit, our parent function is y equals 2 to the x. All right. So from there, we can do a lot of different things when we talk about transformations. So again, like I said earlier, we have A, H, and K. And I'm going to tell you what each one of these things does, just to remind you. So just like quadratic unit, A tells us if it's a stretch or shrink, which means stretch means skinnier, all right, or more narrow, and then shrink is, you can think of it as wider, all right, or fatter. So A also tells us if it's going to reflect or not, all right. If it's negative, then it's a reflection, all right. So negative A would be a reflection over the x-axis. Okay, then B tells us if it is growth or decay, but in all of today's examples, B is going to be 2 because of the parent function. So it's going to be growth for the most part today. All right, so growth or decay. If it's greater than 1, it's going to be growth. Less than 1, it's going to be decay. All right, then H, just like in the quadratic unit, is opposite H. Opposite H. So if it's a positive H, we're going to go to the left. Negative H, we're going to the right. Opposite H. Remember, okay. And then K tells us up or down. All right. So you might want to take a little screenshot of this so that you can always refer back to it during today's activity. So we're going to talk about each one separately. All right. So A, the number in front of our base. So I should go back here real quick. So B is the base. All right. This number only tells us growth or decay. That is the number right next to the variable X. Okay. That's not A. A is in front of that number. Okay. So in this case, we start off with the parent function y equals 2 to the x. All right, a stretch will look like this. Y equals 3 times 2 to the x. All right, this tells us growth. This tells us a stretch by 3. All right, here's another example. Y equals 9 times 2 to the x. Again, the 2 tells us growth. 9 tells us that it's a stretch by 9. Okay, let's do another one. All right, what if I had a negative 7 times 2 to the x? All right, growth. This has a stretch by 7 and also a reflection over the x-axis because of the negative here. Okay. Now let's look at a shrink. A shrink is anything between 0 and 1, okay? So an example of that would be 0.5 times 2 to the x. The 2 still tells us growth, but the 0.5 tells us that it's a shrink this time, all right? Or let's do 1/3 times 2 to the x. 2 is our base. It tells us that it's growth, and then the 1/3 tells us that it's a shrink by 1/3. All right, and then lastly, what if I add a negative to that? Negative 1/4 times 2 to the x. The 2 tells us, again, growth, but then this tells us shrink by 1/4, and it's also a reflection over the x-axis because of the negative sign here. Okay? So that's A. All right? So now let's look at H. Remember opposite H. So H tells us left or right, but it's opposite. So if I have y equals 2 times x minus 5, that means I'm going to the right 5 units, okay? Let me erase that. All right, what if I had y equals 2 times x plus 3, all right? Opposite h, so I'm going to the left 3 units, okay? Just do one more. All right, what if I had y equals 2 times x minus 9? All right, opposite h, so I'm going right 9 units, okay? All right, now let's do k. All right, so k is that constant that sits out to the left. Here's a little thing to remember. K, and if you don't remember this, it's okay. But k is your asymptote. Whatever k is, that's going to be your asymptote. All right, that's just something you might want to hold on to. Put that in your back pocket. All right, so y equals 2 times x. Oh, it's not 2 times x, sorry. 2 to the x. All right, let's say plus 3. All right, that's a shift up 3 units. Okay, y equals 2 to the x minus 3. That's down 3 units. Okay, what if I had, let's say, y equals 2 to the x minus 7. That's down 7 units. Also, my asymptote is going to be -7, okay? If that last part confuses you about the asymptote, don't worry about it. But that's going to be very helpful, and I'll talk a little bit more about that tomorrow. All right, last one, y equals 2 to the x plus 8. All right, that means I'm shifting up 8. And guess what? My asymptote is also 8, okay? All right, now growth and decay. So I can have different things for my base. Now this is the parent. The parent function starts out at y equals 2 to the x, but that could change. I could have y equals 3 to the x, all right? And because of my base, that is still growth. It's greater than 1, all right? What if I have, let's erase this. What if I had y equals 5 to the x? That's still growth, all right? But if I had 1/5 to the x as my base, all right, that is decay. Oh, my writing's getting a little ugly. Let's erase this, okay? So a couple more. All right, what if I had y equals 4 to the x? That is growth, my base, all right? What if I had 1/4 to the x? And a lot of times they'll put it in parentheses like that. That is decay. It's less than 1, between 0 and 1, okay? So if you need to pause anywhere just to look at it and make sense of anything, you can. All right, so now let's put it all together. So again, A is a stretch or a shrink, okay? And it also tells us reflection or not. If A is negative, it's a reflection, okay? B is growth or decay. Greater than 1 is growth, less than 1 is decay, or between 0 and 1, I should say. And then H, so that's that. H is left or right, opposite H though. So if it's a positive H, we're going to the left, negative H, we're going to the right. Okay, and then K tells us up or down, and it's also our asymptote. Okay, so let's look at some examples. All right, so let's start off with the 3 here. That is a vertical stretch. by 3. Okay, the 2 is not really a transformation, but we can make note on the side that it is growth. All right, you don't have to mention that in the transformation, but just know that's going to be very helpful for tomorrow when we're matching the graphs with the equation, that the growth or decay is determined by this middle number here, or the base. All right, then we got H here that tells us left or right, but opposite H. So that's going to be left 4 units. And then K tells us up or down. So that's down 6 units. Okay. All right, so stretch by 3, left 4, down 6 units. All right, let's do another one. All right, so the first thing you should notice is this negative sign here. So we are reflecting over x-axis. And then this 0.5 here, that's A. So that's going to be a shrink by 0.5 or 1/2. The base here just tells us it's growth. We don't need to really write that in the transformation. All right, H is minus 3. So that's opposite H. So that's right 3 units. And then K is plus 2. So that's up 2 units. Okay, so reflect over X, shrink by 0.5 or 1/2, right 3 units, up 2 units. Okay, look at this one. All right, now notice I don't have a separate A out here. I still have my base. All right, that's going to tell me growth. And the base is always next to the exponent. That's how you know it's the base. Okay, so A is technically, there's an invisible 1 right here. All right, in front of that 2. That's supposed to be parentheses. It's a little ugly. All right, so A is -1. So that is a reflection over the x-axis. But the 1 doesn't stretch or shrink or anything. So all we have is a reflection. And then plus 3 opposite H. So that is left 3 units. And then K is plus 5. So that's up 5 units. Okay. Do a few more. All right, look at this one. Reflect over the x-axis because of the negative. We got a shrink by 1/3. So that was A. And then this is going to be growth. We don't need to write that. All right. And then we are going left or shifting left 3 units. Notice there's no K this time. It's really a plus 0, but that doesn't do anything to our graph. Okay. I think this is the last one. So that A is 1, so nothing happens with A. There's no H. All right. All we have is a K. So all we're doing in this one is shifting up 5 units. Okay. All right. So I did want to show y'all what that looks like on Desmos real quick. So let's go there. And then that'll be it. All right. So let's make that small for a second. So here's the parent function in red, y equals 2 to the x. All right, that's what it looks like. It starts out, always goes through 1 is the y-intercept originally before we do anything to it. All right, but let's just say let me just close that off. Let's say I add a stretch to that. All right, so y equals 3 times 2 to the x. All right, see how it gets a little more narrow. All right, it's going up at a faster rate. Okay, let's make a higher number. Let's do 9. See how it gets even more steep, if you will. Let's change it to like 20. All right, it just keeps going up at a faster rate. Notice the asymptote is not changing. All right, we're just going up at a faster rate. All right, so let's change it to, now let's mess with H. Oh, let me show you a negative. All right, if I add a negative, reflection over x-axis. See that? Okay. So let's take that out. All right, let's do H. So X plus 3. Let's do 3. Let me erase this. Come on. It doesn't want to go away. There we go. All right. So look, it just slides over. All right. Looks like 3 units. All right, let's change that to 6. All right, keep sliding left. Let's change that to +9. Just keep shifting left. All right, just shifting left. All right, now let's go back to the negative side though. All right, what if we change this to minus? Oh man, minus doesn't want to work with me. Okay, -4. Let's put the X back there. All right, see, now we're going to the right with the -h, okay? All right, let's change that to 9. See, we're going to the right. 10, okay? Keep going to the right with that -h. All right, now let's take that same one, though, and let's add 2. All right, look what happens. Shifts up 2. All right, let's add 9. Shifts up 9. And notice, remember what I was saying, the K is 9, and that's also our asymptote. Our asymptote is at 9. All right, let's change it. Let's go down now. Let's change it to -5. Look how the graph is going down by 5 now, and our asymptote is now -5. Okay, 7. Went down 7. Okay, let's do one big jump. Let's go down 15. Okay, see, we're down here now. And our graph is -15. So based on what I have here, I have a shift right 10 and down 15. And that's where my graph ends up, okay? And again, if I add that negative in there, what's going to happen? It reflects, see? Okay? All right, so that is it. You're going to